Welcome back. All right, section 5.1.4, solving equations graphically. So solving equations algebraically, besides solving equations algebraically, you can also solve equations graphically. Solving equations graphically can be used to solve all equations, but it can be particularly helpful for very complicated and difficult equations. So that's what we're looking at today. How do we solve equations with a graph? So here are our steps. You're going to graph the left side of the equation and then graph the right side of the equation on the same coordinate grid. So let's do that. Step one down here. We're going to do this first one without a calculator or anything. We're just going to graph it by hand. So the left side's right here. So I'm going to graph y equals x minus 4 quantity squared minus 3. Then I'm also going to graph the right side, which would be x minus 5. So my first one would be a parabola because it's squared, shifted 4 units to the right and down 3. And then it has a stretch factor of 1, so I'm going to go right 1 up 1, left 1 up 1. 2 squared is 4. 1, 2, so right 2 and up 4. 1, 2, 3, 4 from the vertex, left 2 from the vertex, and up 4. And I'm going to go the 3's as well, just to be safe. So 3 squared is 9. So from my vertex, I'm going to go right 3 and up 9. And then left 3 from the vertex and up 9. All right, so there's my left side graphed. My right side graphed is x minus 5. So I'm going to go down to negative 5. This would be a line. I'm going to go up 1 and over 1. And then I connect those. All right, so here's what I have so far. So how do I get my answers? The intersection will be, or sorry, the solution will be where the two graphs intersect. Remember that there may be more than one answer. And then the last step is, since the original equation only has x values, you will only be looking at the x's from the point or points of intersection. So here are my intersection points here. And since my original problem only had x's in it, I'm only using the x's for this intersection. So this intersection point has an x value of 3. So one answer is x equals 3. My other answer would be x equals 6. And I just solved that graphically. Let's do this one. Second one, I'm going to graph y, the left side, y equals x plus 3 quantity squared minus 5. And I'm going to graph y equals 1, because that's negative 1 is the right side. So my left side will be moving left 3 and down 5. And then I do my normal parabola, left 1 and up 1, right 1 and up 1, right 2 and up 4, 2 squared is 4. And then left 2 is up 4. And then I'll do the 3's, 3 squared is 9. So I'm going to go right 3 from the vertex and up 9. And then left 3 from the vertex and up 9. All right, now I'm going to graph y equals negative 1. Remember, y equals negative 1 means I go down to negative 1 on the y-axis, and every y value that's negative 1. So just a horizontal line. Remember, I'm looking for the intersection points. And since I only had x's in my original equation, my solutions are just the x values. So this has an x value of negative 5. and this has an x value of -1. So two answers, x equals -5, x equals -1. All right, try this one on your own. So you'd be graphing the left side, which is x plus 5, quantity squared minus 2. And you'd be graphing the right side, -x minus 5. All right, so I would be moving left 5 and down 2. And then graph right 1, up 1, left 1, up 1. It's a parabola again. Right 2 from the vertex and up 4. And then right 3 and up 9. And then left 3 and up 9. All right, then I'll be graphing -x minus 5. Let's start at -5 and go down 1 over 1. Down 1, right 1. And I'd also have to go up 1 and left 1 here. So this is what I should get. So I have an intersection there, an intersection here. Remember, I only have x's in the original problem, so my answers would be x equals -7, because this intersection has an x value of -7. This intersection has an x value of -4. So x equals -4 is my other answer. All right, one of the benefits of solving equations graphically is that you can solve very difficult equations with ease. That means you can and will have answers that are decimals. That's the benefit of solving graphically. All right, so how do you solve with a graphing calculator? So remember, you're going to press the y equals button on your calculator. You're going to type the left side of the equation in for y1. And you're going to type the right side of the equation in for y2. Then push graph. You may need to adjust your window to get a good view. Remember, you're trying to find the intersection. So if you think that it's going to intersect somewhere outside the window, make sure you adjust your window. So we're looking for the points of intersection. So to get the points of intersection on your calculator, remember you're going to push second, calc, which is above the trace, and then number 5 for intersect. You're going to scroll close to the intersection point and then push enter 3 times. If you have more than one point of intersection, you need to repeat the steps if there's more than one intersection point. And just like before, since there are only x's in the original equation, your answer will only include x values. So let's try doing, on the next page, try doing example 1 here with our graphing calculator. So step 1 was to type in the equation, or actually we're going to write down, so we're writing y equals the left side, 3x minus 1, y equals the right side, 2 to the x. So then I press y equals, and I type the left side in, 3x minus 1 as under y1, type the right side in as y2, 2 to the x, and I press graph. Okay, so it looks like I'm going to have one intersection point here, one intersection point here. I'm not going to have any other intersection points because this exponential is going to grow much faster in the end, so they're never going to intersect again. So now I'm pressing second calc, number 5 for intersect, and I'm scrolling close to this intersection point here, pressing enter 3 times. So we get one intersection of 1, 2. Remember, I'm only using the x value because I only had x's in my original problem. So x equals 1. I'm going to repeat the process. Second calc, 5 for intersect. Oops, second calc, 5 for intersect. And then I want to scroll closer to this intersection point and press enter 3 times. And now I get x equals 3, y equals 8. So again, x equals 3, only using the x values. We'll do one more here. So now I'm using absolute value. So the left side is 2 times the absolute value of x plus 3 minus 7. And the right side is y equals 5. Just remember, you can adjust your window if you need to. I'm going back to the last question. If you weren't sure if they're going to intersect again, you can press window. And let's say you want to just go up higher. Remember, that's how you change the x min, x max, y min, y max. If I wanted to go up higher, I could make this 30 just to double check they're not going to intersect again. And so now I can be really confident that they only intersect at those 2 spots. Okay. And remember, you can always press zoom 6 to get you back to a standard window. All right, going back to the second problem now. I'm going to graph 2. Absolute value is math. Scroll over to number and then ABS. Absolute value of x plus 3. Close your parentheses or your absolute value bars, depending on what kind of calculator you have, minus 7. And I'm graphing y equals 5. So there's my V. I am only intersecting at 2 spots. So second calc, 5 for intersect. I'm just going to scroll close to this intersection to start. Press enter 3 times. And I get x equals 3. Second, repeat it for the other intersection. Second calc, 5 for intersect. I got to scroll over to the other one now. Closer to it now, so I press enter 3 times. And x equals -9. Again, I'm only using my x values because there's only x's in my original problem. So that's how you do it in a graphing calculator. You may also want to do it with Desmos. So if you're going to do it with Desmos, using your computer, go to desmos.com. You're going to do very similar steps. Graph the left side of the equation and also graph the right side of the equation. We are going to be looking for points of intersection. Just like we have been before. To get the points of intersection on Desmos, you must double click on one of the graphs or the intersection points. And points will pop up and you just need to hover over them. Make sure you find both of them. And again, since there are only x's in the original equation, there are only x's. Your answer will only include the x values. All right, so let's take a look at using Desmos. I'm going to use Desmos on my phone, but you can do it on your computer as well. So again, I'm going to graph the left side, so y equals -3, and then graph the right side, -x plus 1 quantity cubed plus 2. All right, so here it is with Desmos. So I'm typing in y equals -3. That was my left side. And then I'm graphing y equals negative, and then in parentheses, x plus 1, close your parentheses, cube that, so I have to press this a to the b, the 3, and then plus 2. All right, so I can put this down now. There's my graph. If I click on one of the graphs, notice these specific points pop up, and I want to find that intersection. So I click on that point, and this is where it'd be really nice. Solving graphically is really nice because I get an answer that's a decimal. that would be a little bit more challenging to solve that algebraically. So x equals 0.71. There will be no other intersection points because it's just a horizontal line. And then let's look at the last one. I'm graphing the left side, -3, square root of 2x minus 5, and then plus 7 on the outside, and then the right side is -8. So be very careful when you're typing this one in. Okay, so y equals -3, and then to find the square root, well, square root's right there, 2x minus 5, and be careful because the plus 7 has to be outside, so I want to arrow over and then plus 7. Notice the plus 7 is clearly outside. I go to the second graph and I type in y equals -8. Okay, I'm going to put this down so we can see the graph a little bit better. Now this is where a standard window doesn't really help me a whole lot here. It looks like they're not intersecting. So I would have to adjust my window, and when I do that, I can now see they're intersecting right here. So I click on it, click on the point, so I get x equals 15. That's my answer. Okay, so whatever way you like to solve this, you can go right ahead and do that, whether you like to do Desmos or your graphing calculator.